Hello. So, throughout your school career, what argument did you come across that you felt was the most atrocious? Um, the most sort of unfair. Just left you feeling that the thing wasn't really explained. So, I'd be interested to hear. But I think one fair candidate is that the integral of x squared, say, or the same for x to the n really, is 1/3 x cubed plus c. Or if you like, that the area under a parabola from x value 0 up to x value k is 1/3 k cubed. So today I wanted to talk about a really nice, really clean way of finding that area under a parabola, or any graph of y equal x to the n, directly. This isn't original to me at all, and I put some links below if you want to read more about it. Of course, it's a very ancient problem, and I would like to do something about the history of the problem. But for now, let's just see how can we find the integral of x squared, the area under a parabola, directly. Okay, so let's start by looking at this integral, then the area under the parabola from 0 to k, and I want to show that's proportional to k cubed. That's my first job. I won't worry yet about the constant of proportionality. I just want to show that the integral from 0 to k is proportional to k cubed. So with that in mind, let's call the integral from 0 to 1 something. Let's call that capital A. And I first am going to stretch out my graph by a horizontal stretch of scale factor k. And that's going to take my graph of y equal x squared, and it's going to stretch it out, and it's going to have a new equation, y equal x over k all squared, or y equal x squared over k squared. Okay, and it's taken my limits 0 to 1 up to 0 to k, and what it's done to my area, well, it's taken a, and it's scaled it up by a factor of k, so it's now the area ka. Next, I'm going to apply a vertical stretch of a factor k squared. Now notice first, that's going to send me straight back to my original equation, y equal x squared. So it's really a symmetry of the parabola, this combination of these two transformations. And it's scaled the area up by a factor of k squared. So my area has gone from a to ka to k cubed a. I've got another factor of k squared in there. But it hasn't changed the limits of my integration, though. It's still 0 to k. So I now know that the integral from 0 to k is k cubed times this constant a. And that's exactly what I wanted. It's proportional to k cubed. Yeah, so my next job, well, now I know that the integral of 0 to k of x squared is proportional to k cubed. I need to work out what that constant of proportionality is. So what is the integral from 0 to 1 of x squared? So actually I can do this by rewriting an area in a couple of ways. So if I think about the integral between 1 and 2 of x squared, now I'm going to compute this in two different ways. So the first way I'm going to compute this is by thinking about it as the integral from 0 to 2 take away the integral from 0 to 1. Now I know that using the previous result, this is just 8 times a, this is 2 cubed, lots of a, and this is just the definition of a here. So I'm left with 7a. But notice that I can also translate my graph, so this becomes the integral of 0 to 1 of x plus 1 squared. And now I can multiply that out using the binomial theorem, so that becomes nothing but a for that first term. And now everything else I can integrate. This is the area of a triangle and the area of a rectangle. So this is 1 plus 1. So all I'm left with altogether is 6a is equal to 2. So a is equal to 1/3. And that's exactly what I wanted. So the integral from 0 to k of x squared is 1/3 k cubed. There. Thank you very much for your attention and for watching. Now, where did I leave that subscribe button?